Hello and welcome back. We've seen in our main notebook where we analyze the damage in dual phase steel that we have used a number of helper functions, and we now go over a number of collections of various utils that we have used and created to do this and focus on them in a separate video. So first of all, because these panoramic images are very large, we need to increase, shall we say, the size that is allowed to read them to a very large number. And we create a little helper function that loads the SEM image, and this is done with the IO library, and it becomes a NumPy array. We've seen that it's handy to overlay on the image little boxes with colors that correspond to different damage types or not classified if we can't assign one, and this is what's done in here. So we pass the image as a NumPy array and the damage site as a dictionary, so that classifies where these damage sites are and what kind of damage we attribute this. And then we loop over these damage sites, take the position, and then change the color. So we start with a default color black, and then depending on what kind of damage we have, we choose different kind of colors. So notice that here we use the match case syntax in Python that is fairly recent, depending on when you watch this video, but not all Python versions have this as part of the syntax already. So if you get an error, you need to replace this part with the elaborate if-else-if sequence of statements. Then we can create a rectangle. We use the patched library here, create a rectangle at a given size and draw the edge or the border around it, and we don't fill it. Then we take this and add it to the image. Here we write the legend, so this is what we do, so to remember what color is what. The key part is preparing the images for the classification in the neural network. And so we take the panoramic image and then we run the clustering, and then each network takes small image parts with a given window size. So the larger one takes 250 by 250, and the smaller one takes 100 by 100. So we make this argument, and what is returned is a list of all of these small image patches, if you want. So we take the panorama as input and take the shape, and then here is the image list that we want to return, and then based on the window size and the centroids that indicate where a damage site is, we sort of put the centroid in the middle of this image patch and then cut around it with a given image size. And then of course we need to catch the cases where we sort of hit the border of the physical image. Because we have grayscale images from the electron microscope, but the networks that we use are naturally based on color images, we sort of need to copy over this information 3 times. So the color image is 1 channel, but we need 3 channels for a color image. So essentially we take our temporary image that we cut out from the panoramic image with a small window size and put this 3 times in there to sort of fake that we have a color image, but each color has the same